Thought I might go live a little bit early. Just sit here for a minute. Hmm. Oh, that yawn lasted so long that it outlasted the delay. All right. Now that we have some people watching, and it's 5 o'clock, we'll think about getting started. Ooh, excuse me. I'm ready for the weekend. How about y'all? I guess this actually was kind of a early weekend start for you guys, since you don't really have much to do. You just got your little quizzes to do, and don't have to be at work. That's nice. All right. The force that pushes electrons through a circuit is called voltage. Voltage is the pressure that pushes electrons through the circuit. If you saw the thumbnail of this video, I had a little piece of artwork that I found on the internet. I don't know who made it. Multimeter must be placed in series to read amperage. That's because one of the natures of a series circuit is that current stays the same. So if you were trying to read current, you don't want it to change. So you're going to put your meter in line with the current. Excuse me. You're going to put it in series so that the current stays the same going through there. Opposite charges attract. That you hear that all the time. Current flows from where there's more electrons to where there's fewer electrons. Kind of talked about this earlier. It flows from where there's a lot of negative electrons away into where there's fewer negative electrons. I say negative electrons. That's kind of redundant. Electrons are negative. Ampacity is an invisible force that can produce heat, motion, light, and many other physical effects. That's what ampacity is. Actually, no. I spoke too soon. Ampacity is the flow of current. Electricity is an invisible force. Sorry, not doing what 58% of you did and just reading and going, yeah, it sounds right. Not actually processing what I'm reading. Should take a nap at some point during the day. That'd be nice. Which formula will you likely use most often as an electrical worker? That is Ohm's law. Good job, guys. Y'all all got this one. Electricity is the movement of electrons that have been energized by an external energy. The unit of current flow is the ampere, which is represented by the alphabetical symbol I in Ohm's law. Yes. Current flow is measured in amps. It is an 1 amp means that 1 coulomb of electrons move past a point in 1 second. So that means a coulomb is a number of electrons. So that volume of electrons past a location in 1 second. An electrical potential of 1 volt will cause 1 coulomb of current to do 1 joule of work. Voltage is electrical potential. Current is, or amperage is current, how much current is flowing. Voltage does not flow. If you see something that says flow, the answer is automatically current. Omega. This symbol stands for omega and is ohms. Okay, this one is the correct one. There's one a little bit later that the words are jumbled, and it's incorrect. But this one is the true one. I'm looking around for a drink. Don't have one. Anytime one is measuring the resistance of a circuit, power should be removed from the circuit. That's because of the way that a meter reads resistance. It sends a small voltage through the circuit and reads the amperage that it gets back. And it changes that into the resistance it's actually reading. If you have extra power in the circuit, it's going to jumble the number that you're getting. It can also damage the meter, but more it's going to give you a bad number. Yeah, so that's the electrons inside the battery. So these are the electrons going. So the current flows from negative to positive. So it's flowing this way. So inside the battery, it goes like that, from positive to negative. Alright. This is just regular ass math. 42 amps divided by 6 milliamps equals 7,000. Okay, so I'm going to do one of these on the board. Alright. So your formula you're going to use here is, let's see. Hey, it came out pretty good. I'm using a drawing pad that I have for some other stuff, but I have a drawing pad and I'm using it, so I'm literally just writing the things, and it's a little bit easier to actually look at the drawing pad than actually look at the screen while you use the drawing pad. I wish I had a display tablet, but those are like $500, and I'm not about that life. I'd say 500. They're like four, like the high threes, mid fours. We'll try to round up to 5. So E equals I times R. Let's see. Damn it. Let's just hit Control Z a couple times. Okay, we're making a black box. Let's make it a little bit smaller. Alright. So, the way this works is if you are looking for E, you cover up E, your formula is I times R. If you were looking up R, your formula is E over I. If you're looking for I, it's E over R. That is how you use this, what we call magic circle. So, we are looking for I, so we're going to do, that's another box. Let's get a pen. E over R equals I. So if E over R equals I, that would be 120 divided by 80 gives you 1.5. That is the formula that we are working on here. This is the same question, basically, just different numbers. So I'm going to show you this again. You just replace the numbers for E. Let me write this. E is voltage. It stands for electromotive force. I is current. And R is, let me use some symbols. Resistance. I haven't written that down all week. This is the first time I remembered. All right. So you plug your numbers in where they go, hit enter. Same thing. Only resistance can use power in an electrical circuit. You'll see this come up a lot. Only the resistance can consume the power. Everything else in the circuit wastes the power. So only the resistance in a circuit consumes the power and does work. Ooh, yeah, this is that. Voltage doesn't flow. That's the trick here. Voltage doesn't flow. Current flows. Complete circuit is a closed circuit. I went through that pretty quick. Non-electrical people will sometimes call an open circuit a short circuit, but it's not. When a circuit is open, voltage does not exist in the circuit. Voltage does exist in circuits. Actually, you could argue that there's... I'm not going to go there. You can read the voltage across a switch whenever it's open. You read across the screws on a switch, and it'll tell you how much voltage is trying to get across that switch. Voltage is just a potential. So whenever you're trying to read in the circuit, voltage is the potential. That's all you get. This one is the Ohm's law that's mixed up. It takes 1 volt to push 1 amp of current through 1 ohm of resistance. Wow. All of you misread this. The numbers are all in the wrong order. All right. So I'm going to put up a overall quiz. You do not have to do it. This is purely a hey, this is stuff for y'all to do over the next couple weeks while you are in quarantine. You can study it. And then in 2 weeks, we will move on to the next set of stuff. Yeah. Fun. All right. You guys have a good couple weeks. Thank you for joining me for the day today. And thank y'all for participating. It's always nice to see that there's people watching the stream. This would be so much harder if nobody was watching the stream. So thank you for coming to the stream.